So the next set of material is about quadratic functions. So as we've talked about, every time we talk about one of these function groups, we're going to be mainly focused on these three skills. How do we graph this function? How do we simplify an algebraic expression involving this function? And then how do we solve an equation involving this function? So some of this stuff we're probably going to be out of the book on. And then some of this stuff will be in the book on. But some of that, even some of that solving stuff, will be doing kind of things from both areas. So notes here will be important because not everything we're going to talk about is explicitly in our textbook. So we're going to start by talking about graphing. So we'll start with the definition. So we say a quadratic function is an equation that can be written in any of these three forms. So we have vertex form, y equals the quantity x minus h quantity squared plus k. Intercept form, which is y equals a times x minus p times x minus q. And then standard form, which is ax squared plus bx plus c. In all of these three situations, we have the assumption that a is non-zero. The reason that a is non-zero, or it needs to be non-zero in these situations, if a is 0 in vertex form, all of this stuff would drop out and become 0, and you're left with just y equals k. That's just going to be like y equals 4. That's a constant function. That's not something that we want to talk about as a quadratic function. If a is 0 here, the whole thing becomes 0, and we're left with y equals 0. That's another constant function, not what we want to be talking about. In this one, if a is 0, this whole first part drops out, and we're left with bx plus c. That's a linear function. Again, not what we want to be talking about. So that's why we have the restriction that a is non-zero, so that we're ensured to be talking about something that's quadratic and not a constant function or a linear function. Is that okay? All right. So the graph of a quadratic function we call a parabola. And the shape of a parabola is basically a U or an upside down U. So we have something that looks like this, or You know, we might have something that looks like this. Well, it wouldn't be a function anymore. So a parabola can be on the side, but a quadratic function cannot be a sideways parabola. So it's a little bit, we got to be a little bit careful with how we're describing that. So yes, if you talk about conic sections, you can certainly talk about sideways facing parabolas, but no longer are we talking about a function, which is kind of the emphasis for this course, is on function. So we avoid that situation. Is that okay with you guys? So certainly that's still a parabola, but not a parabola that we can get from a quadratic function. Okay. In a parabola, there's several key points that we're going to talk about. The first key point of interest is the vertex, which is much like the vertex in the absolute value function, which is just basically the bottom of the valley or the top of the hill, is what we're talking about by our vertex there. So that's an important point. We're often going to be interested in the vertex. It's going to be a necessary point for us to plot when we're graphing, and often will tell us a lot about a situation that's can be described using a quadratic function. Oftentimes the vertex has some special meaning. If you're talking about a story problem, it's often the target of our story problem. Okay, so let's talk about how to find that vertex. So, in vertex form, we can find the vertex just by identifying the h and k. The vertex is the point h comma k. That should look familiar, right? In fact, that's the exact same thing as the absolute value function. Remember that the vertex for the absolute value function was always h comma k. For a quadratic function, if we're in vertex form, then the same thing is true, that the vertex is h comma k. Oops. I should define these not as y's. I should call these f of x's. And the only reason I'm doing that is it makes the notation that I'm about to use a little bit more convenient. So when I write like f parenthesis and then a number, what does that mean in function notation? It means that we're going to plug that number in for x into the equation for f. So basically what we're saying here for intercept form is we can find the x-coordinate by doing p plus q divided by 2. And then we'll take that answer and plug it back into our f of x equation to get the y-coordinate. And in standard form, we can find the vertex by first calculating its x-coordinate by doing negative b over 2a, and then taking that answer and plugging it back into our original function to find the y-coordinate. So let's do some examples of just finding the vertex. So first thing I'd want to do is identify which form my equation is in. Is this vertex form, intercept form, or standard form? Intercept form. Remember, the equation for intercept form is okay with that? So the x-coordinate for the vertex I know is going to be p plus q over 2. What is our value for p and q here? Not quite. It's -3 and +5, right? So notice that in the equation for intercept form, we have subtraction symbols in there. So just like the h's, the p and the q are going to be the opposite sign of what they appear in our function. So when I do that, I get 1. Is everybody okay with that? Of course. To find the y-coordinate now, I'm just going to do f of 1. So everywhere there was an x in my original function for f, I'm going to replace that with a 1. If I follow the order of operations to simplify this, I should do the stuff in the parentheses first. 1 plus 3 is 4. 1 minus 5 is -4. 2 times 4 times -4 is positive 32. So my vertex is the point 1, 32. Is everybody happy with that? Not so bad, right? We just use the formula. So let's say we have this one. Again, first thing I want to do is identify the form of my equation. Is this vertex form, intercept form, or standard form? This is vertex form. So I know in vertex form, the vertex is just h comma k. So in this problem, what is my h and what is my k? 4 and 5. Good. And I'm done. Those are the easy ones, right? No calculation to even do. We just read it off the function. We can tell immediately what the vertex is. How about this one? Y equals 2x squared minus 3x plus 5. That is standard form. So in standard form, my vertex is negative b over 2a, f of negative b over 2. So first thing I should do is calculate determine my values for a and b. What is my value for a? 2. And what is my value for b? Negative 3. So the x-coordinate of the vertex then is going to be negative of negative 3 over 2 times 2. So that's going to be positive 3/4. Everybody okay there? To find the y-coordinate, I'm going to do f of 3/4. So to do that, I'm just going to plug in 3/4 everywhere there was an x into my original equation. and I'm going to simplify this. So according to my order of operations, if I'm going to simplify this, the first thing I should do is the exponent. How do I square a fraction? Well, you just square the top, and you square the bottom. 3 squared is 9. 4 squared is 16. The bell's about to ring. I'd appreciate it if you guys hang out for just like 1 extra minute and let us finish this one before charging out of here. So to multiply fractions, I need to think about them as fraction times fraction. To multiply fractions, I can multiply the tops together and the bottoms together. Here I can reduce before I multiply. So I get 9 over 8. Here I get 9 over 4. And then I have plus 5. To be able to add or subtract these fractions, I need a common denominator. The common denominator I would use is 8. To get a common denominator of 8, I'd multiply the top and bottom of the first one by 2, and the top and bottom of the second one by 8. So that's going to give me 9 over 8 minus 18 over 8 plus 40 over 8. And when I combine these all together, I get 31 over 8. So my vertex is 3/4, 31 over 8. I did post an assignment for this topic to Power School. This assignment would not be due until the class period after the test. So don't make this a high priority, but don't forget about it either. Okay, guys? Yep, have a good day. Thank you for waiting.